Hello all, welcome to Paritranaya. In this class, we shall discuss about the difference between geosynchronous orbit and geostationary orbit. So before that, we need to know about what an orbit is. So we are already aware that an orbit is a place which an satellite occupies to rotate around the Earth. So there are different orbits for different satellites and also different speeds of different satellites. So this is our Earth. A satellite moves around the Earth. It revolves around the Earth. So at different position, at different height and at different speeds. So here in this class, today we are focusing only about one kind of two different types of orbits. One is geosynchronous orbit and the other one is geostationary orbit. About the other orbits, we already discussed in a separate class, so you can refer our other classes for the other orbits. And similarly, these two orbits, they are very important. So when it comes to, this is our Earth. Okay. If you look here, Earth and an satellite is what moving around the Earth. So this is called as orbit. This is called as orbit. So today we shall study about such orbits, that is geosynchronous orbit and geostationary orbit. So most of the features of geosynchronous orbit and geostationary orbit are same with few changes. So we shall discuss with respect to those changes in the last. So first let us look into the similarities. So what are the similarities? Geosynchronous orbit is also a circular orbit. Geostationary orbit is also a circular orbit. So what does it mean? It means there are different types of orbits. Now, if you consider this as our Earth and a satellite is moving around it. So now if you look at this path, it is circular. This is circular. Now there are few other satellites wherein if this is our Earth, the satellite will take this path. Okay, will take this path. So here this path is not circular, it is called as elliptical. So that's why we need to understand what kind of path exists in geosynchronous orbit and geostationary orbit. It is circular. So in the examination, in order to confuse us, they may pose a question like this. So geosynchronous orbit and geostationary orbits, they are elliptical orbits. Okay, if at all they make such kind of statement, so that statement will be wrong. So both geosynchronous orbit and geostationary orbit, they are circular orbits and not elliptical orbits. Important. Next, if you look at again both the geosynchronous orbit as well as stationary orbit, both of them, they are present at an altitude of 35,786 kilometer from Earth's equator. So Earth's equator indicates surface of the Earth. So from the surface of the Earth, so from here, from equator, if you look at this distance, what is the distance? It is 35,786 kilometer. 35,786 kilometer. So if you convert this kilometer into miles, it is 22,236 miles. And both the values are important in kilometer as well as in miles, and we have to memorize it. We have to remember these values, because often in examination, in order to confuse us, what they will do, they will say that geosynchronous orbit is present at an altitude of 22,236 kilometer. So instead of miles, they will make a statement it as kilometer. So we should be able to identify. So when it comes to 22,236, it's not kilometer, it is miles. Okay. So in order to overcome such kind of confusions, so this information has to be retained perfectly. So again, it is the same for both the geosynchronous orbit as well as geostationary orbit. So they are at a height of 35,786 kilometer. Next, it is an altitude from the Earth's surface. But if you calculate the distance from the Earth's center, so now from the equator we saw from Earth's center, from center of the Earth, if you calculate the distance, then it will come to 42,164 kilometer, and if you convert it into miles, it is 26,199. So even these values are important. Even these values are important. So it is same for geostationary geostationary orbit as well. Geostationary orbit as well. Next, the satellites which are present in geosynchronous orbits, they are called as geosynchronous satellites, and the satellites which are present in geostationary orbits, they are called as geostationary satellites. geostationary satellites. Now, both geosynchronous satellites as well as geostationary satellites, they follow the direction of the Earth's rotation from west to east. Direction of the Earth's rotation from west to east. So what does it mean? If you look here, so this is the direction of the Earth's rotation. Now Earth is rotating from this direction to this direction. It indicates west to east. If Earth rotates from this direction to this direction, we call it as east to west. But here it's clearly visible, and we already know that Earth rotates from west to east. Similarly, if you look at the satellite which is present in the geosynchronous orbit, it also rotates from west to east. It is not rotating in any other opposite direction. It is also aligned with the rotation direction of the Earth. So this is also very important. Okay. Now, in order to confuse us, they may make a statement like this: a satellite which is present in geostationary orbit or geosynchronous orbit, it rotates in a direction opposite to that of Earth's rotation. If they make such kind of statement, again that will be wrong. So it follows the direction of Earth's rotation from west to east. As the Earth rotates from west to east, the satellite also rotates from west to east. So it's clearly visible here. Okay, clearly visible. Again, this is same for both geosynchronous satellite as well as geostationary satellite. So as I mentioned, satellites placed here are called as geosynchronous satellites. Satellites placed in such orbits are called as geostationary satellites. Next, geosynchronous satellite has an orbital period equal to Earth's rotational period. Similarly, geostationary satellite has an orbital period equal to Earth's rotational period. So what does it mean? Now, rotational period, or what is Earth's rotational period? So the time taken by the Earth to complete one rotation around the axis. So this is called as rotation. So we know that Earth's rotation period is approximately 24 hours. 24 hours. So what is orbital period here? Time taken by the satellite to go around the Earth. Now here, time taken by this satellite to make one round around the Earth. So this is orbital period. And if you look here, Earth's rotation period as well as this satellite's orbital period, both of them are same. Both of them are same. But this may not be the case with all the satellites. Some of the satellites which are placed in other orbits, they may have different orbital period. But here it's Earth's rotation period as well as satellite's orbital period, both of them are equal. Again, it is an important property of what? Geosynchronous orbit as well as geostationary orbit. So that is why geosynchronous satellite has an orbital period equal to Earth's rotational period. Similarly, geostationary satellite has an orbital period equal to Earth's rotational period. Okay, very important. The time taken by the Earth to rotate once is equal to the time taken by the satellite to revolve around the Earth. A very important property of geosynchronous and geostationary orbit as well as satellites. Next. Okay. Now, until this point, what we discussed, that is about geosynchronous satellite and geostationary satellite, both of them, they were same. Okay. So both of them, they have the same property. Now we'll look at the differences. We'll look at the differences. So let us look into this image. Now this is our Earth. This is our Earth, and here this is geostationary orbit. Okay, geostationary orbit. So now exactly on the Earth's surface, here we have what? Equator. We have equator. So from this image, it is very clearly visible that this geostationary orbit, it is exactly on top of our equator. On top of our equator. So if you look at this line and this line, the angle made is 0. The angle made is 0. So the angle made by geostationary orbit with the equator is 0. Whereas here I have taken geosynchronous orbit. If you look at our equator and this geosynchronous orbit, there is some angle, some degree between it. Okay, it means it is not 0. So it may vary. It may be 1 degree, it may be 2 degree, it may be 3 degree, it may be 6 degree, it may vary. But what we came to know is, when it comes to geostationary orbit, so the what angle formed with the equator is 0, whereas in case of geosynchronous orbit, the angle formed may not be 0. it may be anything, it may be even 0 as well. Okay, it may be 0 as well. So from this we understand that geostationary orbit is a special case of geosynchronous orbit. Geostationary orbit is a special case of geosynchronous orbit. When the angle made by it with the equator is 0, we call it as geostationary orbit. So this is a very important difference to note. So what does this difference make to a ground observer? This is also very important. So a person, now here it is a geostationary orbit, it is not geosynchronous orbit. Why it is geostationary? Because if you look here, this is the Earth's equator, and exactly here the satellite is moving, so exactly on top of the equator. So at every place its inclination with the equator is 0. So now here what I have indicated here is it is a geostationary orbit. Okay, geostationary orbit. Now the difference between geosynchronous and geostationary orbit. So if a satellite is placed in a geostationary orbit, so first we shall discuss about geostationary orbit. So it always appears at the same position. That is, if you look at 10 a.m. the satellite will appear at a particular position. If you look at 11 a.m. again the satellite will appear at the same position. Again if you look at 2 p.m. it appears at the same position. So irrespective of the time, so always the satellite appears at the same position. So it appears that the satellite has been fixed at a particular place. So this is the speciality about geostationary orbit and geostationary satellite. Now coming to geosynchronous orbit or geosynchronous satellite. Now if you look at that satellite at 10 a.m. it will appear at a particular place. At 11 a.m. it will appear at some other place. At 12 noon it will appear at some other place. At 2 p.m. at some other place. But again next day 10 a.m. it will appear at the same place where it appeared the previous day at 10 a.m. So what does it mean? To put it in a nutshell, if today I have seen the satellite at a particular position, then next day at 10 a.m. I'll be able to see that position, that satellite at the same position. So this is the speciality about geosynchronous orbit. Okay, so it will not appear as fixed at a particular position throughout the day, but at one particular time, so irrespective of the day, it appears at the same position. At 10 a.m. today and 10 a.m. tomorrow and 10 a.m. day after tomorrow, it will return to that position. Okay, so this is a speciality about geosynchronous orbit and the satellite which is placed in the geosynchronous orbit. That is geosynchronous satellite. Now, after looking into the difference of geosynchronous and geostationary satellite or orbits, let us move further. So geostationary orbit is a special case of geosynchronous orbit. So as I already mentioned, so that's why it is also called as geosynchronous equatorial orbit, because it makes an inclination of 0 degree with the equator. It's a special case of geosynchronous orbit, as I already mentioned. Now there is an advantage of placing a satellite in geostationary position or geostationary orbit. So what is that advantage? So let us discuss with the help of an example. So let us assume that communication related satellite has been placed in geostationary orbit. So let us take the example of our television. So when we watch television, so whatever the information that has been broadcasted, so it is received through our antenna or dish. So this our antenna, it communicates with the satellite. So it communicates with the satellite, it receives information from the satellite, and that is visible on our television. Now if supposedly this satellite, if it is placed in a geosynchronous orbit, then it will not be always at the fixed position. It will start wandering here and there. So at 10 a.m. if the satellite is in this position, then at 11 a.m. the satellite will be in this position. At 12 noon it will be in this position. So every time the satellite changes the position, then there will be a requirement for us to change the position of our antenna as well, because antenna has to receive the information from the satellite. So we have to change the position of satellite in a day. Okay, continuously we have to change the position. But because of the presence of the satellite in geostationary orbit, there is no such requirement. So only we will fix set the position at the time of installation, and after that we need not change the position, because always the satellite, the communication satellite and our antenna, they are facing one another. So there is no requirement of changing the position of the antenna. So this is the advantage gained by placing the satellite in a geostationary orbit. So this was about geosynchronous orbit and geostationary orbit from exam point of view. So this much superficial information about these two orbits and also the application level information that we discussed, that would be more than sufficient. So with such kind of information, any difficult question that appears in prelims can be tackled. Similarly, the same information can also be quoted wherever necessary in mains as well. So this was about the geosynchronous orbit and geostationary orbit. Similarly, in the forthcoming classes, we'll be discussing about the other important science and technology related topics from the examination point of view. For all our further updates, subscribe to our channel and hit on the bell icon. Thank you.